Today's presenter is Lucidworks Senior Software Engineer and Lucene Solr committer, Steve Rowe. Thanks for joining us today, Steve.
Thanks, Aaliyah. I'll get started then. Before we get started, though, Lucidworks sponsors, as most of you likely already know, the Lucene Solar Revolution, and this year's conference is going to be held October 11th through 14th in Boston, Massachusetts. There's a link there, lucinerevolution.com, where you can find out about it and register if you haven't already. A little bit about me. I previously worked at a research center called the Center for Natural Language Processing, or CNLP, at Syracuse University. It's just north of where I live in upstate New York. I'm now a senior software engineer at Lucidworks, and as Aaliyah said, a committer on Apache, Lucene, and Solr. I'm also a committer on a standard generator project called JFlex, in which Lucene and Solr's standard tokenizer, among a few other components, is written. Stuff we're going to talk about today are capabilities of OpenNLP, the current state of the OpenNLP Solr integration, how to deal with OpenNLP's models, training and licensing issues, part of speech, what it's good for, that is why anybody would want to do it. A technique called lemmatization versus stemming, which is already available in analysis components that ship with Solr and Lucene. And Solr configuration and demonstration of lemmatization and named entity extraction. And finally, some future work that I plan on doing on this topic. So OpenNLP is, in large part, a collection of machine learning algorithms that are applied to various problems. They have a couple of other ones, I think, but maximum entropy and perceptron are the two algorithms that most of the components implement. The things that OpenNLP is capable of doing are mostly listed below. The sentence segmentation, tokenization, part of speech tagging, as I already mentioned, lemmatization, named entity recognition, phrase chunking, for example, noun phrases or verb phrases, parsing, which can find structure in sentences, for example, connections between noun phrases and verb phrases, co-reference resolution, which figures out when you use different terms to refer to the same thing, what the thing is. And finally, document classification. As I said, a caveat, OpenNLP isn't integrated with Solr in any release yet. There is a long-standing patch on a Lucene Solr JIRA numbered there, Lucene 2899, that Lucidworks Grant Ingersoll started actually like 5 or 6 years ago, that has a series of patches that currently works, and I'm going to be demoing that later. And this webinar is based upon a talk that I gave at the United Nations Open Camps. One of them was called Search Camp that I gave a couple of weeks ago. So I'm calling this talk-driven development. I wanted to give a talk about it, so I did some work in order to further the patches that are on that issue so that people can have OpenNLP availability on Solr. I'm hoping, if things go well, that it can be in either Solr 6.2, the next release, or the one after it, Solr 6.3, but we'll see. In the current patch, what's implemented is sentence segmentation and tokenization, part of speech tagging, phrase chunking, dictionary-based lemmatization, and I'll talk later about what that means, and named entity recognition. A little bit about how OpenNLP models can be trained and licensing of existing models. Most phases of OpenNLP's operation can be trained, but not independently of the previous one. So, for example, if you wanted to train named entity recognition, you'd have to make sure that the tokenization and sentence, and for that sentence segmentation, jives with the data that you're going to be using. So you can't mix and match at training time and application time different preceding phases in order, and still expect it to work properly. So that's one caveat. About licensing, the publicly available models, and there are several of them for several different languages for OpenNLP, and I'll give a pointer to those later, are based upon data that are licensed with non-free licenses. So as a result of this, because of the way Apache projects are licensed, the binary models are not packaged with OpenNLP, the project, and can't be packaged when the OpenNLP integration is released with Solr either, it being an Apache project as well, because the licenses are not compatible with one another. This is, as I'll say in a moment, less of an issue than it might at first appear. I mean, you can, if you want to use the publicly available models, you can download them and use them. But more importantly, likely, for production use, the data that was used to train the public models is probably not exactly what you want. So if your use case really does need natural language processing, you probably are going to get involved in training. So I include below an example workflow of how you might do that. Most people will bootstrap from an existing model, and one way you could do that is to take the models that OpenNLP publishes, as I said, separately from their release because of licensing issues, and then use that to tag some training data you've got, and then modify that training data in whatever way you feel needs to be changed so that it appropriately tags it. One way you can do that is using an open source tool called ROT, which is a recursive algorithm, or not recursive algorithm, recursive acronym. You can see there the full name, RAT, Rapid Annotation Tool, BRAT. OpenNLP understands its output format as of release 1.6, which is the most recent release. I haven't used it myself, but its website shows it to have a fairly nice web-based UI, and it's capable of doing annotation at various phases for named entity recognition, for example. It knows how to do that sort of thing. Then once you've modified the training data to be tagged the way you think it ought to be, you can run OpenNLP command line tools to train and create a model based upon the training data. And should you choose to do so, there are evaluation tools available, again, from OpenNLP's command line tool to test the model performance. And depending upon whether you're looking at the results of evaluation, you could repeat that on potentially increasingly larger data or different subsets of existing data you've got until you get to the quality that you want. So this is the Lucene JIRA number, Lucene 2899, on which the work is currently proceeding to add OpenNLP integration to Solr and Lucene. As I say there, it was created in 2011, so it was over 5 years ago. The bulk of the implementation of the most recent patches was written by a guy named Lance Norstad, and I modernized that patch and added support for dictionary-based lemmatization, which is a new capability of OpenNLP 1.6. Short discussion of what lemmatization is good for versus stemming. Both of these can be used to increase what's called recall. That is, recall is a measure of the proportion of hits you get for any given query against ones that ought to be hits. So if, for example, you're looking for the word lemon, and you know you have 30 documents in your corpus that have the word lemon in it, query against your corpus only returns 25 out of those 30, then a recall measure would be 25 divided by 30, whatever that works out to. Both lemmatization and stemming can be used to increase recall by normalizing the terms that are queried. So it can be used both can be used at index and query time to change the query space. That is, the set of terms that are used to match. So if, for example, lemon can occur in several different forms, lemons, for example, the plural, or an adjectival form, lemony, like a scent. Both of these are theoretically capable of reducing all of these different so-called surface forms into the normalized form that can then be used to match more broadly and increase recall. So what are they? Lemmas are real words. Ordinarily for verbs, these are infinitives, and for nouns, they're the singular. An example here. This, pardon me, the format that I show here has a word and a slash, and then a part of speech. The VBG there is a gerund, that is ing form of a verb, and VB is a verb. So speaking and spoke that have been part of speech tagged in the way that I show there, when passed through a lemmatization process, return the word speak. Another one, a noun, NNS stands for plural noun. For the word stigmata, will produce the lemma stigma, which is the singular of that. So lemmas can be produced either by algorithm or via, or I say there, a known item dictionary. The current implementation in OpenNLP 1.6 includes only a known item dictionary, but 1.6.1, which has not yet been released, and I'm not really sure what their release schedule is. But anyway, it will include, they already have committed an implementation of machine-learned lemmatization implementation. So it includes an algorithm that for various languages. I'm not really sure which languages are implemented at this point, at least English. I don't know what other ones. It can similarly to stemming algorithms remove or add patterns in order to arrive at real word stems, not real word stems, but real base words. Again, infinitive verbs and singular nouns in those two categories. I think the ideal would be to use a dictionary for known words, but since language grows, new words are coined all the time, and dictionaries you get were gleaned from somebody else's corpus usually. Combining a dictionary-based implementation with an algorithmic implementation would likely be the best of both worlds, rather, so that when a known term is found in the dictionary, that lemma is returned. But if it isn't, then the algorithm is consulted to produce what is most likely the base form for the given word. A caveat about how lemmatization works and how short queries are not a good fit for it. That is, part of speech tagging is ordinarily trained not on queries but on full sentences, and doesn't tend to perform well on typical, keyword-based searches where people, in various kinds of ways, just give word salad where the individual words in the query don't necessarily relate to one another. They're maybe just keywords that people want to find in a single document, but it's not like something anybody would ever say. As a result, using a lemmatization in a system where you do that kind of normalization on queries that are that short can lead to poor performance. So I don't recommend using it for the typical Google kind of searches where, again, queries tend to be rather short and not sentences. But there is an increasing number of contexts in which people either speak or type out questions or give greater context that can be properly part of speech tag. And then when the lemmatization lookup occurs with the dictionary, which depends upon the part of speech that's assigned to each of those words, it can perform much better. Contrasting lemmatization to stemming, as I said earlier, Solr includes several stemming algorithms bundled in the distribution, and what it produces aren't necessarily real words. I'm giving an example here based upon the Porter stemmer that ships with Solr. The same three words, speaking, spoke, and stigmata, produce differing stems, in part because without a part of speech, in English anyway, words are ambiguous. So spoke could be a spoke in a wheel, which is a noun, and the base form of that word is indeed spoke. Speaking, Porter did well here because it just stripped off the ing suffix there. And stigmata apparently is not the Greek plural there at at the end of stigmata isn't among orders, algorithms, techniques. It doesn't know how to strip that off. So stigmata, not that that's necessarily going to be all that much used. I meant it here just as an example of a problematic category that's coming. Won't necessarily do the normalization you want. So if you go to search for stigma, for example, and a document contains stigmata, when stemming is performed, those two terms will not match. And this is performed via an algorithm. And again, Solr contains several different algorithms and several different language implementations. Back to part of speech tagging. The English models that come pre-trained for OpenNLP for part of speech tagging use the Penn Treebank part of speech tags. And Penn Treebank is a well-known corpus that's maintained by the Linguistic Data Consortium. So there's, I don't know, 28 or 30 of them here that can be used to tag all the different sorts of words you find in sentences. So Solr configuration, what do you need to do in order to use this with Solr? You need to put the jars that will come with the distribution on the class path for the collection or core that you're going to be using. You need to add the required resources to the config set, and those resources are the binary models. And if you're going to be using the dictionary-based lemmatization, you need a dictionary that has the data required in order to do the mapping. And then you need to add field types using the analysis components that are available. And finally, add fields using those field types to the schema. So in order to add the required jars to the class path, you have to edit solrconfig.xml and add these lib tags that include the two directories where in the analysis extras contrib, where the jars that are required in order to enable this functionality live. Then in order to get the models and the lemmatization dictionary, you can download them for several languages, English among them, from the URL that I list there that's on SourceForge. Again, these can't be hosted on OpenNLP's Apache site because of licensing issues. And the lemma dictionary, which I give a link there for, is derived from a project called, actually there are several different lemmatization dictionaries there, but the ones that I'll describe using are from a project called Language Tool, which is it's a tool for people to do correction of text, an editing tool. It happens to know about part of speech tags and lemmas. The way that I have arranged them in configuration directory for a config set is shown here under the conf directory. I made a new directory called OpenNLP and then put in the binary model files there. You can see them for named entity recognition, part of speech tagging, sentence chunking, and tokenization, and finally the language tool lemmatization dictionary at the bottom for English. To add field type and fields. This is kind of a long thing, but hopefully it's laid out well enough so that you can follow along as I describe what's going on here. This is a schema API call that adds a field type and a field using it below. I've called that type text lemma, and it performs tokenization, part of speech tagging, and finally lemmatization using the OpenNLP tokenizer, which invokes OpenNLP's tokenizer, obviously. And the OpenNLP filter factory that's listed there is capable of all of the different tagging operations, including part-of-speech tagging. It can also do chunking of noun phrases, verb phrases, etc., and named entity recognition. I don't show that in this particular case, but with other parameters, those things are possible. And then the OpenNLP Lemmatizer filter factory points to the dictionary that has, it's formatted with Cerberus form word, part of speech, and lemma. That is the term that it will be, the base form for each word. Below there, I just have a new field called content lemma that uses this field type. So I'm going to switch now to show an example of using not exactly the most recent patch, but almost, on Solr. Pardon me while I switch. So what we're looking at now is Solr's admin UI. And I've created a core that I called OpenNLP and applied the modifications that I just described to it. We're looking at the analysis pane, which can show you at each phase of analysis the transformations that were performed by each step. So now I have to think of some example. Let's see. Terrible sentence, sorry about that. The analyze values. So if you're not, let me see if I can make that a little bit bigger. That should work a little bit better. After tokenization, you can see that it split it apart as you would expect. One difference from standard tokenizers that are included with this Solr and Lucene is that in order to perform part-of-speech tagging and other forms of tagging, OpenNLP needs to tokenize punctuation. So you can see there the period at the end of the sentence is separated out rather than dropped and included so that it can be tagged further on. This version of the patch used payloads to encode each of the different kinds of tags that it could be performed. I don't have an ASCII table available right now, but for example, the word to 4344, I don't know what that is. Apple's, I believe, is NNS, says 4E, 4E53, which is a plural noun. I'm looking at the ONLPF, which is the OpenNLP filter is the name of that one. And its payloads here. I can't select in that way, sorry. And the lemmatization filter has reduced that word apples to apple. And in the case of 2, just lowercased it. I made a sort of poor choice of example here because I don't see much else lemmatization that's going on, but I think you get the flavor of what's going on there. In the most modern version of the patch, rather than using payloads, on the advice of several other committers, I've changed to using the token type here. So the default type for Lucene and Solr analysis is just word, which you can see here on all of these. But in the latest patch on Lucene 2899, I've switched it so that rather than encoding tagging as payloads, the part of speech tags and other tags are placed in the type attribute. Let's see. I have another, I didn't show the configuration for it, but I have another field defined called people that uses a named entity recognition to define people. So I'm going to enter in an example sentence that should be able to find a couple of people in. That's not going to work. No. So I'm thinking of different forms of named entity recognition that can be performed. The way OpenNLP named entity recognition is trained, and I suppose you could do differently, but the way that it's trained is that only one class of named entity, and the one I'm going to demonstrate is people, is identified. So in trying to come up with an example, I'm thinking of other forms of named entities, but I haven't set it up to be able to do other named entity recognition. The component as it currently exists in the OpenNLP Solr integration is capable of performing multiple named entity recognition tasks in sequence, and you can specify them in a single field type. So if you wanted to, you could identify people, places, organizations, dates, that sort of thing. And OpenNLP has trained models for each one of these in English anyway. And then have those populated. Let me finish this example. And so in the second filter, the OpenNLP filter below, for some reason it hasn't labeled it as payload, and I'm not going to be able on the fly to, well, actually I am, because I happen to know what this is. This tag, these hex numbers are for person. So when there is no tag, then it's not identified as a person. each of these tokens, John Brown and John Paul, were identified as a person. And then what you would want to do is coalesce sequential ones with the same tag. So I'll talk about it a little bit more later, but I think ideally, rather than have tagging, or maybe in addition to tagging, it would be possible to have a Solr update request processor that runs named entity recognition and pulls out and coalesces the tagged people, places, organizations, states, all these things into terms that are stored in dedicated fields for those things. And I plan on doing that, creating such a component in the future, not done yet, on Lucene 2899 before I committed and included on a release. But without that, right now, you could, for example, use existing filters in Solr analysis to take the token type and store it as a payload in the index, and then perform queries, for example, for people that, for terms that have the people, or rather person annotation. Alternatively, in the most recent version of the patch on 2899, I've added a new filter called type as synonym that puts annotations, either part of speech or named entity, or and I haven't shown this, but the phrase chunking, which is included in different implementations. I put those annotations as synonyms, that is, tokens at the same position of the term that was tagged with that annotation. So you could, for example, do positional queries that find, say, a person with a particular name next to an organization with a particular name within the same, within 5 words or something like that, using span queries. Let's see. I think that's about it for the demo. I'll switch back. Almost done. Just a little bit about the future work. As I mentioned, I think I consider it a blocker to committing that it doesn't have at this point update request processors that can do population of dedicated fields for named entity recognition, that knows how to do the tagging and then coalesce them. And similarly for phrase chunking, which tags individual words, and then you have to find contiguous ones with the same annotation and pull out those terms as the equivalent of, word n-grams or shingles. One other thing I want to do before committing is optimize memory usage. Currently, an entire document is loaded into memory and sent through processing rather than the minimum that's required for these components to be trained on one sentence at a time, so they don't need larger context. I think the only reason that it was done the way it is just expediency. So I'm going to look at increasing efficiency of memory use there. And finally, of course, committing and releasing this work. I have a list of URLs there. And we're a little bit under time. This was supposed to run about 45 minutes. Alea, if you're there, I think we're ready to do questions.
Great. Thank you, Steve. So we will now begin the Q&A portion of the session. If we do not have time to get to your questions, someone from the Lucidworks team will reach out to you. So feel free to keep entering those questions into the chat box on the bottom left of the screen as we go. So the first question that we have for you, Steve, is what is the level of effort needed to train custom models?
That's an interesting question. In my experience, it depends upon how much data you've got and how many people you've got who can perform the annotation and how close existing models, for example, public models, are to what you want. So let me switch back to the example workflow I gave for training. So if you start from a model that's already fairly close, you have a fairly small amount of data, and you only need to make a few tweaks here and there, and you have multiple people who can perform the work, then it can be done fairly quickly. That probably isn't, if you need this kind of thing though, that's not very likely. It's fairly likely you have at least access to a fairly large set of documents that you probably don't have annotations for right now. I mean, there is another case, of course, which is you already have your own set of documents and annotations that were produced for some other effort, in which case it's just a matter of formatting them so that an OpenNLP training can make use of them, and that's ordinarily fairly trivial. I'm struggling to come up with a single answer because it depends upon your context. It's likely that if you're going the route of any of these tagging technologies, you're gonna have your own data, and it's not going to be small, and somebody needs to do the annotation. So it can be a fairly large investment if you want to get it really high quality. Another aspect to think about is maintenance. So often you're performing this sort of task against not a static set of documents, but ones that change. And as they change, the models that you've trained on older snapshots of your data will become less and less relevant. So there's an upfront cost in generating the models to begin with, but then you have to consider the sort of a process where at some regular interval you look at performance of those models against current data and decide whether you need to do more training. So that sort of maintenance cost needs to be figured into an estimation of what this would cost overall. But just to get, if this is something you're interested in exploring, I think just as an example, the project includes trivial data that's used to run tests to make sure that these processes work. And that data, is just a few, it's just a few sentences in some cases. So this process works on trivial data. And if you wanted to explore, you could look at those tests and see how they operate, and even start there so that you wouldn't have to run the manual command line tools. If you start from the tests that are with Apache, it automates the process of creating the models. So as I said, you could just go and edit those data files and perform your own training. So just learning about it, it can be fairly, you could in a day likely run through something close to that workflow that I mentioned for trivial data. And then scaling it to real data, it could take some time. But again, that depends upon factors like how much data, how many people you have to work on it, and how good the quality needs to be. hope that answers the question.
Thank you. The next question is, what is the quality of any Rs generated from OpenNLP compared to core NLP?
I don't know. I haven't looked at comparisons of efficacy. Sorry, I don't have any information there. I think OpenNLP doesn't have a huge committer base and isn't all that active. I think core NLP has more people working on it, and it's more active, and so it's likely that the quality is better. But I don't think that it can be directly included with Solr because of licensing conditions. So OpenNLP, because it's another Apache project, doesn't have that issue.
Thank you. The next question is, how can OpenNLP play well with explain parameter in the query?
I'm trying to think through what that means. So essentially, the question is asking the explain parameter in a Solr query will show elements of scoring. So it'll show you the factors that contribute to score for each of the hits that you get back. I don't think this would be any different from standard, and I confess that I haven't actually tried it myself, but I don't think this would be any different than the standard operation, where what you see is each of the elements of a query that have been, after it's been processed for whatever form of normalization. For example, if you've added synonyms or performed stemming or lemmatization, as we talked about here. So I guess it should work fine. That's my uninformed opinion.
Thank you. The next question is, what happens when you implement NLP and people use short keyword-based queries?
Yeah, as I mentioned, so implementing OpenNLP and using lemmatization specifically, as I addressed earlier in the talk, because lemmatization depends upon, at least in English, the part of speech tagging process preceding the lemmatization process. If part of speech tagging can't be performed with good quality, then lemmatization results won't be good either. And because if the sorts of queries you're dealing with are Google-style keyword queries, short ones, that aren't in the form of sentences and could just be, word salad, as I called it, but just a jumble of unrelated terms, the part of speech tagging you get is likely not to be good, again, because it doesn't match the context in which part of speech taggers are ordinarily trained, which is full sentences. One thing I don't know much about, but which may possibly address, at least to a certain extent, some of the problems here, is to actually train on short queries. I haven't seen any discussion of how that would perform. I suspect it wouldn't fix the problem entirely, because part of speech tagging depends upon surrounding terms in order to determine context, and then apply appropriate transformations apply appropriate rules encoded in the model to change part of speech depending upon the words that are around it. So if you can't if you can't use those features, surrounding words and their parts of speech as indicative of expected parts of speech of terms in a short query, then I don't think you're going to do that much better. But it almost certainly would be better to train on a corpus, a set of short queries that you have manually tagged with the part of speech that they're supposed to be. If you had a model of that you trained yourself, then it would almost certainly perform better than one that was trained on full sentences. As I say, I suspect that wouldn't fix the entire problem, which is structural. That is, people aren't speaking in sentences. Words are not ordered, or they don't relate to each other in the way that ordinary sentences do. My recommendation earlier in the talk was if you expect that you're going to have short queries, especially if you don't have the resources to train a model for part of speech tagging on those short queries, then I recommend against using it in that context. That's it.
Thank you. The next question is, how well does OpenNLP support other languages, such as Dutch?
So if you look at the resources page, that is the last page in the presentation, which I've just switched to, the models page has a listing of all the available pre-trained models. I don't know specifically for Dutch what the support is, but there's nothing about the Dutch language that I know of anyway, that would prevent you from doing your own training if you have data and you want to. You'd have to train each of the phases, that is sentence segmentation, tokenization, part of speech tagging, and then if you wanted to perform further tagging after that, and likely you would, right? That is named entity recognition or phrase chunking or perhaps lemmatization. That is available as an option for you with OpenNLP as it is.
Thank you. The next question is, will OpenNLP interpret the what, how, when, where, how old is type questions? For example, will it transform the when to some time period answer?
So the questioner is asking whether OpenNLP will do all the work of a question answering system for you, and the answer is an emphatic no. So it's the beginning of the sorts of things that you would want to be able to do in order to implement such a thing. Grant Ingersoll, who's the CTO at Lucidworks, has written a book called Taming Text that specifically uses OpenNLP in order to drive an example question answering system. So if that's something you're interested in, I recommend looking at that text. In fact, the issue that the Lucene issue we're talking about, Lucene 2899, was started by Grant with the idea of taking code from his book, Taming Text, and donating it and making it into a module. It didn't work out that way because somebody else stepped up, Lance Norskog, as I mentioned, and provided an alternative implementation. But yeah, there's lots more work to do, and I recommend you take a look at that book, Taming Text, and see what it has to say about the other sorts of things you need to do in order to create such a system.
Thank you. Next question. Can you create your own categories of entity types, or are you restricted to those provided by OpenNLP?
So I have not run through the training process on named entity recognition myself. but based upon the documentation, you can perform arbitrary labeling. That is, if you have a type that you want to identify as that particular type. And one example of this might be, rather than just having people or person as, rather than having person as the only annotation of that type, you might want to have, say, gender reflected in that label. You might want to have female person or male person as the label. And if you provided data that had, and the training is just for one of these labels at a time. So if you trained a model that knows how to identify female person, and then separately male person, you would be able to use those, as far as I know. So in answer to your question, yes, that's possible.
Thank you. The next question is, how does the system handle words with the same spelling but different meanings, or homonyms?
So homonyms often are different parts of speech. One of the examples that I gave to show the difference between, I'm going to switch to that slide. One of the examples I gave to show the difference between lemmatization and stemming is the word spoke. In the absence of a part of speech tag assigned to it to say that it's a verb or a noun, it could be either a spoke in a wheel, that is a physical thing, or a past tense of the verb to speak. For the purposes of lemmatization, if that's what we're talking about, and perhaps the original questioner would like to clarify, because I'm not sure, so I'm going to confine my answer just exclusively to lemmatization. In the context of lemmatization, the part of speech will be able to distinguish between these two homophones because spoke has a different base form. In the noun form, it's the same as the surface form, it doesn't change. And in the verb form, when it's speak. In cases where homophones don't have different parts of speech, I guess there could be cases, I can't think of an example at the moment, where homophones are the same part of speech but refer to different things, in which case the base form might be different. Sorry, I can't think of one. So I guess to answer the question, when homophones have different parts of speech, lemmatization knows how to handle it properly. That's what part of speech is for. In other cases, it will fall down and won't serve you properly. And I can't think of an example, so maybe that's not that common. That's it.
Great, thank you, Steve. So we are just about out of time. Everybody who registered for the webinar will receive a link to the recording shortly. Again, if we did not have time to get to your question, please look out for a note from someone on the Lucidworks team. If you have any remaining questions, feel free to email events@lucidworks.com. Thanks again for joining us today, and we hope you enjoyed the webinar.